welcome back to my Project Euler series in Python. We're on problem 7, the 10,001st prime. By listing the first 6 prime numbers, 2, 3, 5, 7, 11 and 13, we can see that the 6th prime is 13. What is the 10,001st prime? So that's a relatively straightforward concept of just calculate prime numbers and count them as you go, and when you find the 10,001st one, print it out. So let's see if we can give that a go. So let's remove the hello world. Okay, so let's see if we can figure out how we can count. So we're going to need some kind of counter, I guess. So count equals 0. Or we could just say prime count maybe. I mean, it doesn't really matter, but yeah, that's the number of primes that we've counted so far. So while prime count is less than 6, we need to start with a number. So let's say number equals 2. Because we know that 2 is the first prime, and just the logic in the maths doesn't really work on what I'm about to do. So I'm trying to now count the number of times number is a prime and iterate that. So we've got number, so if is prime on number, then we can say prime count plus equals 1, and then number plus equals 1, and then we should be able to print number, because if the prime count gets equal to 6, then number will be here. So maybe we need to do this before. So this is slightly messy on the first case, but it saves it being messy later. So I guess I prefer this way around. And then is prime, obviously we need to make that. So let's just call it n for simplicity. So 4, and then we can just, oh god, what's happened here? And then yeah, for simplicity, we can sort of cheat and look at problem 3 again. So it's a prime factor that's sort of incorporating how the sieve of Eratosthenes works. And I could use the sieve of Eratosthenes for this because that is used for generating primes, but I'm just going to use the normal dividing by factored approach, because I think it's slightly easier than doing the whole sieve up to a certain number of primes, but if you wanted to go up to a limit, then I think it's a bit easier. So yeah, for the I in range up to the square root of n plus 1, it's if n is divisible by I at any point, then we can return false. However, if it makes it all the way up to the square root and it was never divisible by I, we can return true. So let's print number. So hopefully we get a list of primes up to however many there are, so 6. So we should get the first 6. So 1, 2, 3, 4, 5, 6. Yeah, and the 6th prime is 13, which is why it's printed out twice, because we print it again here. Okay, sweet. So I'm hoping this isn't going to be too horrible to just scale up. So I can stop printing number. So the sixth prime is 13. So the 10,001st prime. Okay, I'm pretty happy with that. I mean, I guess it's not the fastest thing in the world, but I mean, in the grand scheme of things, 10,001 is, you know, I knew the prime wasn't going to be a massive number, and yeah, 104,000 going through every iteration. Maybe I could have done number plus equals 2 once we get to 3, I guess. I don't know. What I mean by that is, if we start on like 3 and we know we've already got like 1 prime under our belt by that point, because we've got the prime of 2. In fact, we'll have the prime of 3 as well. So if we have 2 and 3 in the bag already, and the number is 3, then it gets immediately bumped up to 5. So we don't even need to deal with 4. So then we remove all the even options. But to sort of scale that up for all the other numbers is a bit difficult. So to keep it relatively simple, we start by already incorporating 2 and 3, and then immediately jump to 5, and hopefully that gives us the same thing. Yeah, and it should have run it a little bit faster. I don't know if we could tell, but I guess it was already pretty fast. But yeah, so this is our classic prime code, which isn't that great, but like I said, the civ Eratosthenes would just be a bit long to do up to a certain number of primes. So this is what we've gone for. Seems to work fine. 104,743. So let's hope after all of that it's correct. 104,743. Nice. Okay, so that is problem 7. Let me know if you've got a better way to generate some primes in Python, up to a specific prime, like to the nth prime. That'd be great. Up to a limit is fine, but I know that this of Eratosthenes can do that relatively straightforwardly. And we might need to use that again in a later video anyway, so you might see it soon enough. Until then, I will see you next time for problem 8.